All right, so today's lesson focuses on complex Boolean statements. We're going to take what we learned last chapter with the more simple Boolean statements and then expand them a little bit more. And then we're also going to look at nested conditionals. So really we're taking two topics from last chapter, expanding them a little bit further and looking at how they apply to game design. So just to refresh your memory, Boolean expressions are expressions that evaluate to be true or false. So last chapter we had some simple expressions like x is less than y. You'd look at the variable values and you would decide true or false if that statement was true or if that statement was false. Same thing with the bottom one. You'd look at the variable values and decide if that was true or false. So we're going to take the same concept and expand it a little bit further. So all complex Boolean statements do is they take two or more simple Boolean statements and put them together. So for example, you would say x is less than y and let's say z would have to equal a. Or you could have something like 4 is less than s or b does not equal x. So essentially all it does is it combines these simple Boolean statements here that you see, the 4 that are underlined in blue, and combines them to make something slightly more complex. So there are two common ways that simple Boolean statements can be combined together. The first is something called the AND. So essentially what we do is we form a conjunction, and we are saying that this simple Boolean statement has to happen as well as this Boolean statement to happen for that conditional to run. So both of the Boolean expressions need to be true. If one of them is false, the program won't run. So this is really appropriate, for example, if you have something where you need two things to be happening in order for your code to run. So if you look down at the bottom, what you'll notice is we have two Boolean statements here. So we have, if we use these first numbers in number 1, we'd have 2 times 3, which would be 6 is greater than 4. So that would be true, and x plus y, so 2 plus 3, is equal to 5 and true. So because we have both statements that are true, this whole entire first statement, if it was x is 2, y is 3, would evaluate to be true and the code would run. However, if you look at the second one, it says x is 1 and y is 4. So if you look carefully, we know that 1 plus 4 does in fact equal 5. However, 1 times 4 is not greater than 4. And because both of those statements are not true, this statement with these values in number 2 would evaluate to be false. So what I'd like you to do very, very quickly here is decide if these 4 statements will evaluate to be true or false. So pause the video, decide whether each statement would evaluate to be true or false if it was inside of a conditional, and then I will show you the correct answers on the next slide. So you can see here that the only statement out of these 4 statements that evaluates to be true is the first one, because both of those conditions, both of those simpler Boolean statements, are true. The other ones, because they have a false and because we are using this AND right here, they would both need to be true. So the other 3 evaluate to be false. So just a special note about the AND, because there is a very unique application of this, especially related to math. So oftentimes, like I teach Algebra 1, and students will represent an inequality saying that x essentially has to be sandwiched between 5 and 10. It has to be larger than 5 and also less than 10. And in algebra, we can represent that using a double inequality. So 5 is less than x is less than 10. However, that statement is not valid in code, and we have to have another way to represent that. And the way that we do that is we use the AND that we talked about on the previous slide. So we actually split it up into 2, and we conjoin them with the and we say that x essentially has to be bigger than 5. We can see that right here. And then we say x has to be less than 10, and we put the and in between. So notice that we cannot use this first chunk that you would normally see in algebra, but we can fix it by using the and that we just discussed. So the next thing that we can use is we can use something called the or. Now, the font that I chose here made that look a little weird. All that is 2 vertical signs, and when we get to the lesson where I actually have you type these into code, I will tell you where they are on your keyboard so that you can use them. But the or is similar to the and in which it has 2 simple Boolean statements connected, but this is a little bit different. The or is used when one or the other can be true and the code can run. So maybe you want the game to end when you lose your lives or when the time is up. This would be an excellent time to use an or, because it only evaluates to be false if both of those statements are true. So for example, we have some similar letters up here. You can see x times y is greater than 4, or x plus y equals 5. So this one we would have 1 times 4 is greater than 4. We know that would be false, but because 1 plus 4 is equal to 5, we have one that is false and one that is true. We just need one of those to be true, and as a result, this first statement here with these numbers will evaluate to be true. Then if we do the same thing with 2 plus 2, so if I erase that there, you notice that 2 times 2 is not greater than 4. That is false. And 2 plus 2 does not equal 5. So it's false or false. This is the one time when, because both of those statements happen to be false, with 2 and 2, this whole complex Boolean statement would evaluate to be false as well. So I'd like you to do the same thing here that we did on the previous slide. You'll notice that each of these have or, and you'll notice I actually use the same statements. 1 is greater than 2 versus less than 2 and 10 and 20, but this time I just put the or in between it, and I want you to notice the difference that occurs when we're using the or versus using the and. So again, pause the video, try these 4 on your own very quickly, and then you can check your answers on the next slide. Alright, so if you compare when we have the and versus when we have the or, you'll notice that 3 of these statements actually evaluate to be true because we only need at most one of those simple Boolean statements, one of those conditions to be true. So if one of them is true, the whole statement evaluates to be true, and then from there that piece of code will run. The only one that will not run is this 4th statement, and that is because it has 2 statements that are false, none of which are true, so it would evaluate to be false, and that chunk of code would then in fact not run. So another just little side note, sometimes it is helpful for kids to use parentheses. They don't like just having the statements linked together with ors and ands. So please note that you can add parentheses to make things more clear. So this statement right here underlined in red is the same thing as this statement here underlined in red. I've just placed parentheses around the simple Boolean expressions. And the same thing here with pink. This is the same as this. Again, I just use parentheses to separate out and say this is a simple Boolean statement and this is a simple Boolean statement. So use if you wish, but there's no pressure to do so if you can read it just fine without the parentheses. So the next thing that students will start to ask is, well, can I use multiple ands and multiple ors? And if you look here, number 1 contains all ands. So if you have a string that's linked with a bunch of ands, all of those same rules apply. If you have all ands, then all the statements must be true to run the code. And then the same thing for number 2, because we have ors, and we're using all ors, just one statement of all of those simple Boolean expressions must be true to run that code. So if there's multiple ands and multiple ors, the code runs just as it would with just one and or one or in the statement. So what I'd like you to do next is up above you will see that we have values for x, y, and z, and what I would like you to do is evaluate number 1 and number 2 and decide if each complex Boolean statement would evaluate to be true or would evaluate to be false. And then once you're done, I'll show you the solutions on the next slide. Alright, so here you can see that first statement, because the first and the third of those simple Boolean statements are false, that entire statement would evaluate to be false. You need all of them to be true if there's multiple ands. And then the second statement, which contains multiple ors, because 2 of those are true, we just need one of them to be true, and as a result, that statement will evaluate to be true. So where complex Boolean statements start to get tricky is when you have ands and ors mixed together in the statement, because there are times that depending on the ands and the ors that are in there, depending on how you evaluate them, you can actually get a different result, whether it's true or false. So something to note as we move forward is that the and has a higher precedence than the or. So what that means is that you always evaluate the and first. So there's kind of like an order of operations to evaluating Boolean statements. So just like there's PEMDAS in math, in Boolean statements, the and is always evaluated first, followed by the ors, which are second. So you evaluate your ands first from left to right, and then you evaluate your ors second from left to right. So you have to apply that order of operations, and while it doesn't happen often, there are situations where if you don't evaluate the and first, you will get a different solution. So again, what I'd like you to do is pause the video here, try these two problems, remembering that the and is always evaluated first, and then you can check your solution on the next slide. All right, so here I kind of tried to color code how to find your solution. What you'll notice is I put in purple what we need to do first. So you'll see that I did this chunk in purple first and found that using those values up above, that and statement evaluated to be false. And then I had false and then the or part left, so it was false or false. And as a result, because of that, we end up with a statement that is false overall. Now, in the second one, we did this part in purple first because the and has a higher order of operations than the or, and so we evaluated that first. That part ended up to be true, and as a result, we then had false or true, which in the end evaluates to be true. So just remember that order of operations when solving complex Boolean statements. That will come into play a couple of times, especially when you start making your own Booleans, noting how those are going to be evaluated and how your computer will actually come up with whether the statement is true or false. So just one more slide to really reiterate that. In your order of operations, the and comes before the or when you're evaluating complex Boolean statements. All right, so what you see before you are 8 different complex Boolean statements, and what I would like you to do with each one is decide whether it will evaluate to be true, evaluate to be false, or if the code is written in a way that is invalid and would need to be fixed before putting into code. So again, pause the video, decide if each one is true, false, or a piece of invalid code that could not go into a conditional evaluating to be true or false. All right, so you can check your answers here. For the most part, students tend to do okay with ands and ors that are simple. Where these get a little complicated are numbers 5 through 8. So a couple things I want to just touch on. First, this statement here, remember, is invalid. While we can do that in algebra, we would need to split this up into an and statement in order to actually run that in code. So that number 5 is invalid. In number 6, remembering that the and needs to come first, so that must be evaluated first. Same thing with number 8, so we have the ands that are always evaluated first. And then in number 7, I wanted to see if you would catch on to the use of parentheses, knowing that number 6 and number 7 are the same, except for I captured the or in parentheses. And just like your order of operations, that or will now come first because of those parentheses being there. So pay very, very close attention. Sometimes parentheses always communicate that you should do that section first. So as you move forward, just kind of keep complex Boolean statements in mind. You can now stop this video and move on to the next one concerning nested conditionals.